Today I'm going to walk you through how our asset teams utilize WebGIS to break down data silos and collaborate across disciplines. Before WebGIS, there was no authoritative source for spatial data. Shapefiles were emailed back and forth, and people were making decisions with outdated information. As a data-driven company, we knew we needed to solve this problem, and the GIS Portal has become our authoritative source for analytics-ready spatial data. Our homepage has the most frequently used maps and apps highlighted for our users. We provide links to helpful resources, including online training classes and how to view GIS layers in other software. A new feature we found is our ability to customize the app launcher. Here we link to external web platforms, creating a single launching point for users throughout the company to find the data sources that they need. We have created groups for all of our asset teams, whose members consist of Geo Scientists, engineers, and land. Users are also able to create their own groups for smaller projects where they only want to share with a few others. Let me walk you through an example of how our asset teams are using Portal in their daily work. Our Geo Scientists spend the majority of their time working in Kingdom. They create subsurface models and plan new wells. Here we have a maximum curvature seismic map with highlighted colors representing faults. For geos to be able to plan wells, they need to see land data on the map. Spatial Explorer can consume many different formats, but most importantly for them is the ability to connect to our portal. All right, I've already loaded some data, so let's take a look at that. They can now stream lands data into the map, eliminating the need for manually loading shapefiles. Another cool feature we've been working on with Kingdom is publishing geologic maps directly to Portal. I'll be giving a talk on that at 10 a.m. tomorrow if you'd like to see how that works. Most of our asset teams have geoscience technicians maintaining a web map for use by the team. Let's hop back into Portal and take a look at that. So here you can see the same land data they were viewing in Kingdom. Since they published the curvature map to Portal, anyone can now add this to a web map. Now this seems so simple, but for the first time, our engineers, landmen, and managers can view the exact same data our geos have access to in Kingdom. So next, let's look at our Aries database. We have this symbolized by producing wells, PUDs, probables, and possibles. If I turn off the leases, you can visually see how the wells are drilled and planned to avoid faults and karst features highlighted on the seismic map. So with just these three layers, we already have a powerful team collaboration map. So our geologists have pointed out that the area to the southeast is free of faulting and is yet to be drilled, and recommends that our land team looks for the available leases. So with this map saved and shared with land, they work with brokers in the field to find some acreage. The shapefiles are emailed back to them and they load them in their content. Let's take a look at that data. They can easily display this on a web map and share it back with the rest of their team. But before we buy these leases, engineering is going to need to take a look. Engineers can use this map as their starting point to load existing production data. Using DI's Excel tools, they can download production data, save it as a CSV, and quickly display it in the map. Let me symbolize this based on 3 different attributes. Okay, here you can see orange represents NGLs, blue represents gas, and the bubble size shows cumulative production. So based on this data and economics in Aries, they have determined we should use a 400-foot spacing and can drill 10 wells in this unit. Let's take a look at what they came up with. So this was just a simple example of how geoscience, engineering, and land each can contribute to a team map. If needed, anyone can export this to a PDF using our pre-configured templates, which can then be emailed or printed. At team meetings, this map is front and center, being used to discuss everyone's contributions and sign off to proceed with drilling. Our approach of allowing all users to publish their own content has led to a massive increase in adoption and collaboration in our asset teams. Okay, back to my team's work. How else have we made asset team collaboration easy? We include every group's system of record data, including land, reservoir, production, and drilling. We also register all oil and gas-related map services from government agencies at the federal and state level so they can overlay it with internal data. We have moved away from FTP downloads and live stream the map services directly from vendors. In total, we serve up over 300 authoritative map services with thousands of layers, enabling our users to create almost any map they desire. Because we leverage Portal, users can also open their existing web maps in Pro if they need to do more advanced work. A natural starting point for these users is to simply open the web map they're already familiar with. From here, they can customize as needed, make their own print layouts, and perform geoprocessing to help answer more complex questions. Portal is a self-service collaboration tool that my team manages. We have found it to be much more efficient to allow users to upload data and create their own maps, helping GIS not be a bottleneck. Okay, so what else does my team work on if users are making their own maps? So besides curating all this awesome content, we get to focus on other fun stuff like advanced analysis and model building to help solve problems. I'll show you two examples of things we've recently done to support our asset teams. Here's a project where EnerVest is going into an old field and drilling new wells between existing producers. We are working with our reservoir engineers to help them determine how many possible new locations could be drilled. Yellow represents the drillable area based on our unit data and buffers around existing wells. The black boxes are potential locations with predetermined spacing, azimuth, and lateral length. By creating a Python script, we are able to quickly automate this task, saving someone weeks of work trying to do this by hand. The end result has more than doubled the amount of potential locations our engineers thought were available. Moving to the next example, this is a well we are drilling surrounded by a microseismic star array to monitor the completion. Along each of these red lines, they would typically deploy thousands of geophones on each arm. Our geophysicists have been experimenting with the pod design, which will decrease the number of geophones needed by 75%, greatly reducing the cost of data acquisition. To run different scenarios, we created a geoprocessing tool that allows them to experiment with different pod sizes and spacing. This has allowed our geophysicists to try different iterations on their own, reducing design time before exporting the final version to give to the vendor to deploy in the field. At EnerVest, GIS touches all aspects of our business. Whether you're a geologist, engineer, land, or executive, you have the ability to make data-driven decisions using maps with the most recent data. Our asset teams are not unique. From A&D deciding where to buy the next deal, to the teams in the field operating the wells, maps play a business-critical role in their day-to-day work. The GIS portal increases efficiency by giving our users the tools to serve themselves, while the GIS team focuses on content management and automation. Thank you.
Thanks, Nathan.